So we're continuing our discussion about radioactive atoms. And now we're going to look at an important concept called half-life, which you might have heard about before. So to do it, we'll look at an example of a radioactive element that we haven't seen before. This one is iodine, which is number 53 on the periodic table. So it has 53 protons. And this particular isotope of iodine is called iodine 131. So it has a mass number, we know, of 131. And let's draw the atomic symbol, number 53 and 131. So here's what iodine looks like. It's a non-metal, but it's still a little bit shiny. It looks a bit like carbon, the graphite form of carbon. So if we have some iodine 131 and we look at all of those, or if we look at 100 of those atoms, there's actually trillions and trillions of atoms, but if we just look at 100 of them, so we've got our iodine 131. Here are the 100 atoms in our little diagram. And remember that a nucleus decaying, when it's radioactive, the amount of time that it takes is completely random. So one nucleus might decay straight away as soon as we pick up, or as soon as that element is made. But then another nucleus of iodine, it might take years and years to decay. And the amount of time that it takes it's hard to measure because they're all taking a different amount of time. So the way we actually measure it for a whole element is we say, how long does it take for just half of those atoms to decay? And that's the half-life. So the half-life is the time taken for half the atoms in a sample to decay.